Hello, welcome to this presentation. My name is Yolanda Robla and I work for HP. I work on Openstack Infra related projects. And today I'm going to explain a successful use case of, it's an automating OVA image deployment using OpenStack infrastructure tools. Okay. So I'm going to explain how was the old workflow and how have we improved it using some tricks and using the OpenStack Infra tools that we are having, like Jenkins, Nodepool. So initially, let me check it. That was the old workflow. We were using Gerrit and Jenkins as well. First of all, engineers were just sending changes. They were sending changes to Gerrit. Jenkins was running tests there, and all the code was pushed into Git repositories. But then we have like a manual step. There was an engineer. It was creating a manual change. Was triggering a manual change to build the image, the OVA image, and it was quite a static process. We need to have an SX host to generate all the image because our process was just creating a cookout2 image from the code that we were generating, and then we were transforming this cookout2 image into our OVA image. We were relying on a static SX host to achieve it. And then after the OVA image was generated, we were uploading that on a static server. It was a very static process because you need to rely on SX hosts that aren't really useful to spin up, to configure. And we were also uploading and downloading a ton of images. There was like two steps of uploading and downloading. It made this process very slow, and it couldn't scale. It was very network intensive as well. Okay. So I'm going to explain you how we will improve our new process. That's the new process. In the start, it's pretty similar. Engineers are still sending code changes to Gerrit. They are using Jenkins to run the test. But then, instead of using an SX host, we are relying only on Ubuntu host. There's a periodic job that it's happening. All the engineers are creating the tests, submitting code to the repos, and once a day, or whatever you need it, an automatic process is spin up. It generates a process into Jenkins, and it relies on Ubuntu host to perform on this process. The cookout2 image and the OVA image is happening now on the same node. We're still escaping all the SX host usage, all the upload and download images there. So we're making this process easy to scale and faster because there is no need of image upload and downloads. It's network intensive, so it's becoming very useful. Also relying on Ubuntu static host make it easier for us to use tools like Nodepool, where you can just attach some nodes, some trusty nodes that you don't need anything there to configure. You just need to spin up the process there, and the image will be generated very fast, and then it will be uploaded to the static server as well. It allowed us to improve this process a lot, really. So how did we manage to do that? Generating OVA images is normally a VMware very tight process. You need a static host, and it's a very common problem. So we need several tools to achieve it. You need an image conversion tool like QEMU, and we also need some VMware client tools. For example, you need the VMware Evidence Manager. We need OVF tool. And you can see the address where you can download it. There are tools for Ubuntu, and they are easy to have it. And you can have all this workflow integrated into Jenkins, into Nodepool, so it's automated. I'm going to explain it step by step. First, we are assuming that you have your cookout2 image already generated. It's done with disk image builder or another process that you have. Once you have it, you need to convert it to BMDK file. You need to use a tool like QEMU EMG converter, and you need to specify the LSLI logic adapter type. It's very important to make it work with the SX host. Then this image will be generated in a sparse format, and this won't be running on an SX host. You need to convert it again, to convert the format. You need a tool like VMware Disk Manager to achieve it using this command that you can see there. Once you have it, it will be generating like two types of images. You need the converted one and a flat one. Then you have your VMDK image ready. You need to convert it to OVA because it's the image that you are targeting. To use that, you can use tools like OVF tool. It's a just simple step, and you need to grab the VMX file, and you are converting that with OVF tool. So you need a VMX container file. It's like a text file that is grabbing all the VMDK image into a set of settings, and you are enclosing that into a container, and you are using OVF tool to publish it. And then after that, you just can upload it to the static server and start using that. So, for example, I'm going to show you a bit of what the VMX file is. I mean, it's a set, just a plain text file with a set of settings. Important to have there is to point to the VMDK file that you have generated before. You need to put the correct path there. You need to use a SCSI file, SCSI format, to point that to the image, because SX host will need it. Also, I mean, you need to use the LSI logic file, as explained before. And once you have it, it's very easy to just generate the process, generate the image with OVF tool, and you are done. I mean, and we achieved to improve the process really a lot, because instead of relying on a lot of static machines, you are just using dynamic Ubuntu nodes, and it's very fast and very scalable. I wanted just to explain a bit of that successful use case. So if you have any questions, that's my email. If you want to know more about this process or about a generic Openstack Infra tool, I will be glad to help. Okay. So that's all. Thank you.